Hello everyone, let's solve today's LeetCode challenge, which is largest submatrix with rearrangement. So here in this problem, we are given a binary matrix of size m cross n, and we are allowed to rearrange the column of this matrix in any order. And what we have to return is the largest submatrix within this matrix, where every column of the submatrix is 1 after reordering the columns optimally. Okay, so let's say in this given example we can rearrange these columns and in any order so that we have to get the maximum area with each one in it. Okay, let's take this example and discuss further on over this problem. 0 0 1 1 1 1 1 0 1. So how do we calculate the area in this? So maybe we can start from any row, or maybe from each row one by one, and whenever we get one, we'll also track the height from that element. So maybe in this example it is 0 0 1. If it is a 1, we will just track the height, and we have to capture the result in a square or rectangle order. So this would be our candidate from the first row, which is having area as 3. Okay, so from second row, from here we can go till 1. From this one we can go till 0. From 1 we can go till 1 and above as well. So how do we do that? So maybe we have to check for all the possibilities from this one, this one, this one, or maybe from all these two pairs, or maybe using all three elements and checking all the scenarios wherever we can form a rectangle or square. So this is going to be n cube solution. So we have to think of something else which is a better in sometimes in terms of time. So why don't we just make all these rows independent? Because in the previous approach, here we haven't reordered the column optimally. We are just trying to solve the problem straight away. So if we have to rearrange the column, that is also going to add too much complexity. So why don't we just make the rows independent in the starting? 1 1 1 1 0 1. If we have to make these rows independently, why don't we just make it from the starting? Starting row is anyways going to be the same. For the second row, we have to calculate the area. So why don't we just pre-compute how many ones we have already visited from the starting? So the first row will become something like this: 1 1 and 2, because it is representing the height, the number of ones before it. Okay, so now for the third row, what would be the result? 2 0 and 3. 3 is representing that height of ones in this case, and 2 is representing height of 1 in this case. Okay, so now we can process these rows independently. So for the first row the answer is 1. For the second row answer is 3. 1 1 1 we will take. For the third row, either we can take this height or this height, which is 3. But we are also given that we can optimally sort or arrange these columns. So if we make these two column together, let's take for the third row 2 0 3. If we, let's say, rearrange it in a manner like 0 2 3, so these 2 and 3 will be together. So now in this case our area will be 4, so which is more than 3. So by rearranging the column we can get a better result. And how do we do that? Make arranging all the items in the column in a fashion where it will be having minimum difference between each element. So maybe in short, we are just going to sort these elements. So firstly we did is, firstly we will make all the rows independent, and then we will sort each row and calculate the answer. So by making the row independent, we will use the previous row every time, and sorting we can do by any inbuilt function, and calculating answer is like let's say for the third row it is 0, 2, 3. If we are at this index, it means we don't need to do anything. If we are at this index, it is representing that all the elements after that is having height at least 2, or maybe height more than 2. Okay, so how can we calculate the area? Base into height. So height is 2 for sure. Every element is going to have a height of 2. So the base length can be calculated like n minus I. I is the current element, which is 0, 1, 2. Let's say I is 1 here, and n is 3. 3 minus 1 is equal to 2, which is 2 elements. So 2 is height and 2 is base, which is equal to 4. So for each index we will calculate the answer using ith element into base length. Okay, now let's try to code this problem. Firstly, let's capture the row value and column value. Matrix dot length, matrix I dot length. We are given that it is of size m cross n. Okay, let's also store our answer to capture the result later on. Now we have to iterate over this matrix. For I equal to 0, I less than m, I plus plus. J equal to 0, j less than n, j plus plus. Okay, now like we don't have to do anything with the first row, so it should be greater than 0, and whenever it is 1 we are going to change it. If it is a 0, we are not going to process it. If matrix of I j is not equal to 0, or maybe equal to 1, in this case matrix I j plus equal to matrix I minus 1 and j. Okay, so now we have calculated the current row, so why don't we just process it, because we this row is independent, so we can process it right away. So let's take it in a different integer array current row, because we are going to sort it later on. Matrix of row dot clone. Now sort this row. Current row for int k equal to 0, k less than n, k plus plus. This row is sorted. We just have to capture the answer from this row. How do we calculate that? Current element, current row k into length of this window, which was n minus k. Okay, now we have calculated the answer as well. We can just directly return it. Let's try to submit our sample test cases. Matrix I dot length should be matrix 0. Where is it missing? It was a closing loop for 4. We have to return answer here. Submitting the problem. Sample test cases are passed. Submitted successfully. Okay, thank you guys.